Let's go. Hi, my name is Brian. I'm here to hack on some Tiger Beetle. Tiger Beetle is a financial database written in Zig. The project we are doing on this stream, though, is to create a Rust client for Tiger Beetle. We've been doing this stream for a number of weeks now, and we're doing the entire project on stream, front to back, every single moment. Every brain cell I spend thinking on this project, we're doing right here. And I expect it to last for a number of weeks still, but all in all, it's going to amount to a complete Rust project, all on stream, front to back. And it's a small Rust project, but it's an interesting Rust project, I think. Captures a lot of what Rust is about. It's got network programming, async programming, a bunch of FFI stuff, issues of data representation, build system integration. I think it's pretty quintessentially Rusty. And today we are going to do a little work on, we're going to try to implement another type of request. So recently we've been implementing requests. There are 8-ish request types in Tiger Beetle. And we've been kind of churning through implementing methods to call every single Tiger Beetle request. And as we go, we kind of learn more and more about how the Tiger Beetle client works. And also we refine our understanding of how users need to interact with the client. Pardon me 1 second. Ooh. Okay, so, oh my gosh, I'm a little horsey. So as we've gone, we've kind of, give me another second. Sorry about the stream. Well, that's a bit of a nightmare scenario, but we'll push through. I suppose this could be a coughful stream, and I apologize for that. So we've been kind of refining our understanding of how to design this API for Tiger Beetle over a number of weeks now and a number of streams. And we started by building, just 2 method calls or 2 request methods. And they shared a lot of duplicated code. And then we extracted out that duplicated code into some helper methods that were very generic that those requests could call. And then we went on to implement some more methods. And on the last stream, we discovered, maybe 2 streams ago, we discovered that the new types of requests we were implementing had some different properties than the previous requests. And so we went back and debugged how these new requests worked and then updated our internal abstractions and kind of updated our mental model about how the client needs to work and how the client server protocol in Tiger Beetle works. In particular, in the last stream, we learned that while some requests will accept multiple events per request, kind of like multiple requests packed into one message, the new requests we've been working on only accept one event at a time. And we had to kind of understand why that was and update our API and how the internal abstractions worked. And we found some unsafe bugs related to unsafe creation of Rust slices. And we debugged all that on stream, and we got to the point where we had almost implemented one of these new request methods, but not quite. Pardon me again. So today I'm going to go finish implementing that request, and then we're going to move on and try to get one more done. So let's move on to the code. And again, I seem to be very froggy today. I gonna be kind of miserable, perhaps. Oh no, maybe I have a cold. Let's see. Can you see my screen? Yep. Okay. And the first thing I'm going to do today is just kind of catch up our code base and understanding of where we were. It's been a couple of weeks since I've rebased in particular. So I'm just going to go clean up this history and get rebased and kind of reset for some new work. So first thing I'm going to do is, look at my history here. This is all just kind of temporary commits, and it's all built off this one commit. I'm just going to squash all this history down. I'm going to say git reset to that particular commit that I'm built off of. And I'm going to git status, and this should have all of my code here. I'm just going to put that into one commit. And again, this commit history is all going to be meaningless until we get closer to the point of submitting a PR. And I'm going to go ahead and push that because I'm confident that I haven't broken anything. It requires a force push because I rewrote history. And now I'm just going to go back into the Rust directory here. I think it's in source clients Rust, and run a cargo check. Cargo build, kind of prime in my workspace. Pardon me again. And we don't have any unit tests here, so I have not written any tests yet, but we're going to get to a phase where we go think about tests more. So there's not a whole lot else to do here, but what I actually want to do is I want to rebase. So I'm going to git fetch origin. I'm just going to rebase and then kind of make sure everything still works as a baseline. Get rebase origin main. Okay, so there we go. And then I'm going to go back into the Tiger Beetle Rust client directory. And before I build the client, I need to rebuild the TB client library. So this project is just bindings to a Zig library called TB client that implements a common Tiger Beetle client implementation shared by all of the Tiger Beetle clients. So we're not writing like a complete client implementation in Rust. We're just binding the library written in Zig. And eventually we may do a pure Rust library because there's performance reasons to want to do that, and also build system integration reasons to want pure Rust and not C or not Zig. But now we're doing bindings. And so first thing I need to do is kind of rebuild that library. So I'm going to use the Tiger Beetle build command, clients C. And again, eventually these two build systems will be integrated, so you can just run one build command and you'll get the library built as well. But at the moment I have to rebuild it by hand. And then over here I'm going to do a cargo check, cargo build again. And I also want to go ahead and do a little smoke test to make sure everything still works. And to do that I need to start the server. And I think I actually want to recreate my database because I've been using the same test database here called 00 Tiger Beetle for a number of weeks. And it's kind of just polluted with data and I don't really know the state of it anymore. So I just want to start over from scratch. So I'm going to remove that database and create a new one. To do that, you have to run Tiger Beetle. I'm going to say format, and then I'm just going to let it tell me what the arguments are. Okay, we need replica count equals 1. It says I didn't past that? Format. Oh, there it is. Path is required. 00.tigerbeetle is the path to the database. Then I need replica equals 0, I think. And you notice here, I try to just put it at the end of the command line. I want to, this is a kind of a minor annoyance to me, but I hit this every time I do this, is that it's telling me I need the replica option, but I can't put it here at the end. I have to move it back over here. And it's just kind of like a fallout of how the command line parser in TigerBeetle is written. But I expect the program, as it tells me like the arguments I'm missing, that I can just kind of like keep adding those on in order. But no, I got to back up and say -- replica equals 0, I think. Okay, now I can run the server. I'm going to say start. And again, just let it tell me what the arguments are. Okay, now I should be able to run our little test program. We have I'll show you here. Test program. This is, not a unit test. It's just whatever we need to smoke test at the moment. And right now it's doing some transfers and calling this get account transfers. And this, I assume this is going to panic because I don't think we finished implementing this last time. But I'm just going to run it and make sure it seems to be doing something sensible. I'll say cargo run is probably enough. Interesting. Addressed to the wrong cluster. That's interesting. Huh. Okay, this is kind of fallout from rebasing, I think. You can see here the server is outputting these errors. My client is hard-coded to claim that it's talking to cluster 0. And this server is using cluster I don't know. So internally, like, the cluster has an assigned number. And I'm not entirely sure what it's used for, but maybe just exactly this type of sanity checking. And it used to be that it would force me to say what cluster number I'm using in the server, and it didn't ask me to do anything with the cluster number. And apparently, the default is not 0. Often TigerBeetle reserves 0, so maybe the default is 1. And in general, I do think it's great for the command line to give you default arguments. I even kind of wish it didn't require me to give an address. Let's just see if our assumption is right, and we can switch. You can see here on the client, this is just looping, trying to make this request. This is very interesting. Like, is there a timeout here? So this is all internal to the TB client library. My bindings don't implement any kind of loop. But the library seems to be just looping, trying to make some request. And I'm wondering if it'll ever time out or what. Anyway, let's just go back to our test code here. And presumably when we create the client, we specify the cluster. I'm guessing it's this. I might as well give it a variable, cluster equals 1, because we're going to guess that it's assigning cluster 1 to every, by default to the database. But I don't know that. And I think the database itself is assigned a cluster. It's not just that the server is serving for a cluster. Every database is dedicated to a single cluster, I assume, I believe. Okay, let's try with cluster 1 and see if it works. And it doesn't. So we got to figure out what cluster this is. Let's actually go into the parser for the database. Actually, let's go format. I think when you format, you specify the cluster. Let's just say help and see if it gives us some information. And unexpected help, great. A lot of times the UI experience in TigerBeetle is primitive. Yeah, I can't even say help after format. So here in the demo in the examples for help, it does say cluster 0 as the suggested cluster, but it did not force me to enter the cluster after I rebased. So I'm really wondering what the default here is for cluster. All right, let's yak shave, y'all. Let's do some yak shaving and go look at the CLI code for the server. So here's the server here. And I need to find, give me 1 second here. It smells like burning in my room. And I'm hoping it's just my partner baking. She's making a cheesecake. And I hope that the act of making cheesecake creates burning smells. Nothing in my studio appears to be on fire. But it is going to aggravate my already scratchy throat. Anyway, what are we doing here? We're going to look at the source code for the Tiger Beetle main function right here. The main program is in the Tiger Beetle directory here, main. And I'm not exactly sure what we're looking for. Here's a switch over format. Here it says clusters, args cluster. So I'm guessing this args is defaulted, probably in the CLI module. Let's go look for cluster. Right here it just says null, so it's not defaulted to a number, it's defaulted to a none or a null. Format cluster, REPL. One of the arguments of the REPL is a cluster. So the REPL forces you to take an argument to the cluster, but the format doesn't. Let's look at start real quick. Start does not require a cluster argument. So when we format the database, we say what cluster it's for. But it didn't ask us to format the database this time. I'm wondering now if this is in the release notes for whatever version introduced this change. Because usually I have to say the cluster. And let's go down to back to main, in the command format is what we're looking for here. So let's say fun format. Right here, here's our args, args.cluster, format, fun format. It did not use the cluster field of args. Here's args.path. Can we init the command? Command init superblock, VSR format, storage allocator options. What is options? Maybe it's in options? I'm really kind of wondering here what's going on with this cluster field. Let's go back up here to cluster. Oh, okay, I see. It's passed into the options here. So it's not using args inside the format method. It's putting args directly into the superblock options right here. So options is passed to VSR format. So let's go look at the VSR module. Okay, now we're yak shaving. I thought this would be a feature of the command line that it defaulted the cluster. And you can see here it's logging the cluster, but this is presumably a null. So this superblock options, presumably the cluster field of this is also nullable. So let's go to VSR and look for the format. Not in here, so it's going to be in the VSR directory somewhere. And I don't know much about the VSR. Probably, let's actually go to the command line and rip grep it. CD VSR RG format. Looks like it's in, no, not that. Replica format. Looks plausible. Oh, there's so many things called format here. Superblock format, maybe. Maybe. Client, journal, replica. What is the thing we created over here in the main function? What type? Sorry, main.zig, not main.rs. Fun format, superblock, created a superblock. All right, so it's definitely going to be here in superblock format. Here's our format options. 3, 1, 2, 3. Although this doesn't look like the same function because this takes 2, 3, 4, 5 arguments, and this takes 3 arguments. This does not really look like the same thing. Superblock init, it's a superblock is, where's VSR? VSR.format. Gotcha, this is a free function. This is a free function, not a method on superblock. So it's probably not in here actually. It is probably in, what is the VSR.zig importing? Testing VSR.zig. So this module, VSR.zig, is exporting a format function, but I don't actually see it explicitly mentioned in VSR.zig. This definitely points to my lack of deep understanding about Zig. I should be able to guess exactly where this format function is. Anyway, I'm going to go back over here to the grep. I'm going to guess it's maybe replica format. Replica. Oh, format. There it is. I thought I grepped for that format. It's in replica format. VSR, replica format, function format. Here's our options. This options contains our field that says what the cluster is. So let's look for options.cluster. And I'm going to go look at this type real quick and look at this format options type and see if that cluster is nullable. I'm really kind of confused at how this nullable value gets so far into the VSR before it's given a concrete value or a default value. Kind of confused. Superblock type. Superblock format options. That is not nullable. So at some point, this already has been converted to a concrete number. Superblock format options is right here. Format options is right here. I bet I know what's going on here. Let's go back to our top level of the CLI. I think there's kind of a 2-stage process for getting the CLI arguments. I think they're initially parsed directly, and then they're kind of like post-processed to convert them into enums and other programmatic values that are more amenable to actually using. So if we go here to format, I'm guessing these args are not the args I thought they were. These args. So let's go back to CLI and again look for cluster. So this is the cluster that is parsed, and you can see that's nullable. But I bet if we keep searching through here, we'll find another format args where the value of cluster has been defaulted. There we go, right there. So that's the thing that the main function is looking at. So somewhere this cluster is defaulted. Oh, it's it's random. The default cluster is a random number. Why? Why is that? Oh, cluster ID. That makes it so inconvenient for me. That's very curious. I'm sure there's a good reason. Somebody did this for a reason. I'd be curious to read the PR though. Just randomizing the cluster. So I guess the idea is that, like, if I can guess, like in production, maybe it is just too much of a burden to like keep track of cluster assignments. If you run a bunch of clusters, like the cluster number is kind of meaningless. It just has to be unique. So maybe you don't want to actually bother keeping like a spreadsheet of all your cluster numbers. So you say maybe just assign a random cluster and then just take whatever value is assigned to that cluster. And you got to store it somewhere because the clients do have to pass the cluster number. I wonder if, yeah, it's very interesting. I wonder what the purpose of the cluster number is. If it's just for like validation that you're not accidentally connecting the wrong database or what, because it just seems like burdensome. Like this code seems to be trying to make it easier to not have to deal with the cluster number, but the client still has to have that cluster number. Maybe this not using 0 is more of a, okay, I bet it's an attempt to prevent you from making mistakes where you're just like using cluster 0 everywhere. Anyway, we've solved the mystery, but we got to go make a new database now because I don't want to remember that random number. So let's go get our command line all back how we want it. And let's go format this database again. But this time we're going to say cluster equals. First, let's do it without cluster equals 0. I want to see that warning printed. In the code, it's complaining because I already had the database formatted. Interesting. Okay, so it generated a random cluster ID. That's my cluster ID. But in the code, it also said, oh, okay, so if you do use 0, it's going to give you a warning. They really don't want you accidentally using 0 for all your clusters. I'm guessing that's what's going on there. Cluster equals, but we're going to use 0. Got to delete that database again. Yeah, there's the warning. Shouldn't use cluster 0, but we're using cluster 0. Now we can go run this test. Oh, but in our test, I changed cluster to 1. So let's go back and change cluster to 0. And let's put that here as well. Cluster is now a variable. Cluster 0, cluster 0. Why did the server stop? Oh, I'm not running the server. Got it. Run, start. Now we're running the server. Okay, now it's doing stuff. Oh, message addressed to wrong cluster still. Cluster equals, oh, I put a 1 right here. This should say cluster. Okay, that all looks right finally. There's a transfer. Okay. And that panic is expected because our this method that we're working on is not actually implemented. Finally. Okay, I don't think we're going to need to run this anymore. Let's just commit these tiny little changes to our test harness and go back to the library. And now we can get going. 35 minutes in, we can finally get started on the task. Isn't that how it goes? Okay, so let's go see what method is incomplete here. Here's our to-do. Submit get account transfers. And in the right hand, I'm going to open some other method as a reference code. So I'm going to crib off of this code over here on the right while I write new code here. And the whole deal here is that this submit get account transfers only supports one request at a time. It returns multiple results here in this vector, but only one input request. The requests we've implemented so far support multiple inputs, and for each of those inputs, there is one output. So multiple inputs, multiple outputs, but there are one-to-one on the previous requests. This request has one input, multiple outputs. So we kind of got to go rethink how we're dealing with our results here. And so this collect results method here, the whole point of this collect results method is to do the correlation of the responses with the requests, and we don't need that logic anymore. So I do probably need to go look at collect requests to remember, what actually needs to be done to handle the requests. But interestingly, like some of this code, I don't need this big loop here. but I do need some of this like preliminary error handling code. So I'm kind of like seeing some more refactoring in our future, because I'm going to, right now, I'm just going to go copy paste this code. So all this code is going to be the same, but the way we interpret this result slice is going to be different. So all this big loop here is dedicated to zipping the results and the requests back together. And what I need to do, I'm just kind of thinking about whether I want to, de-abstract these types right now. And I think I kind of have to, versus going and taking this and extracting this. I don't know. I'm going to go ahead and open code it here, but pretty immediately we're going to just extract this into another generic function, I think. So here I'm going to look at the types here and make sure we got the types okay. This is okay. And here is we need to figure out what the result type is. It's probably going to be a TB account. No, that's an input type. It's going to be a transfer type. So for every method here, we have a Rust defined request, a C/Zig defined request type, and a Rust defined result type, and a C/Zig defined result type. And so we kind of got to keep those all in mind as we're writing these methods. And this is a type definition for the C result type, which is going to be, I believe, a TBC TB transfer T, because this is get account transfers. So we're looking up transfers. And this is also TBC TB transfer T. So what we're going to do is we're going to iterate over these results and convert them into Rust result types. And one of the things that I said before, it's going to be a lazy stream, I think. I said before that I do all my thinking about this project on stream. That's not entirely true. I do a little bit of pondering before I get on stream. And earlier I was just thinking about the efficiency of having a separate Rust type and a separate C type for every request and response. And right now we have a conversion step. And oftentimes we're dealing with, buffers and or vectors of these types. And if we're converting from, for example, in this case, a vector of the C result type to a vector of the Rust result type, that is going to entail an entire reallocation of that vector. And that is inefficient, less efficient than it could be, which sometimes doesn't matter. But this is a very high performance piece of software. Like the database is high performance, and very high performance and high optimization is expected in this stack. So having extra allocations when we don't strictly need them is probably going to end up being undesirable. And especially Tiger style in particular does a lot of work to keep the representations of data types, consistent all across the stack, so they can simply be like mim moved around. And so this approach we're doing right now, I feel like it's kind of like a more pure design, but it's not going to hold up forever in Tiger Beetle land, where we have to kind of reallocate an entire vector just to do a conversion of its elements. Eventually we'll have to be more clever than that. Let me take a sip real quick. Every time we get into the guts of these methods, I kind of got to reiterate that, I know they're pretty inefficient right now. So anyway, the point of what we're trying to do is we're going to take these results, and I think in this case, all we really need to do, one more digression. So right now we're returning a future of a vector, and we could get around this efficiency problem by returning like a future of an iterator or something, or maybe in futures terms, maybe a future of we probably do an iterator. We don't need any asynchrony, but you could return a future of a stream, an async stream. but we might do a future of an iterator in this case. And that way we wouldn't have to deal with the reallocation. The caller could reallocate. They could collect that iterator into another vector if they wanted. And that would allow us to kind of keep the exact representation we want in Rustland while doing the conversion and not forcing another vector allocation on the caller. But who knows? We'll explore that in the future. Yeah, the idea of converting this into a future streaming API in some way is interesting, but future work. So I think all we really need to do is iterate over this result type and do a conversion, and then pass it back as a future. So let's try that and just see what happens. So we're going to say, all right, we're already in an async block, so whatever we write here is going to be a future. Result.intoIter dot map. And here we should be able to just say into, let's pass a higher order function into the map. And then collect into a vector. And this should all type infer exactly how we want, hopefully. That's very cute if this does type check. Let's try it. Cargo check. Naturally, not everything works the first try. It's pretty universal. Okay, I made some mistakes up here. Fence. I see. Let's go up. I'll explain it in a second. So this create packet function, we're copying this from elsewhere. And what we have here is this create packet function. All right, chat, sorry, I need to be on the WSL OBS scene. I do that all the time. Sorry about that, chat. Sorry about that, future YouTube. Let me see, do I need to show you anything that I missed here? Yeah, so let's go back. This cute iterator. Our goal here is to collect these results, which are defined as terms of the C structures, into another vector that's defined in terms of the equivalent Rust struct. And so I'm just converting this vector, although this is not a vector. I've actually cast a slice. This is an unsafe cast of a slice. So when we receive this was a slice of bytes. We do an unsafe cast to a slice of a type, in this case, the TB transfer T. So I actually can't convert this into an iterator. I just have to iterate over it. And I'm going to iterate over that slice of C types and then just pass into the map function, the into conversion function, just generic conversion function. Should type infer. And then this collect will collect an iterator into some container. In this case, that container is this vec, and it's all wrapped inside of a future. And then I built over here, and the build didn't work because of this error right here. This generic create packet function that's shared by all the requests is creating a packet out of a slice of events. And in this case, we only have one event. So that's an easy fix for us. We just have to put this event into a little slice. And let's see what it thinks now. This events is actually an event. And okay, interestingly, this event, we're passing it as a reference, but that's probably not the right thing to do here. We want to probably pass this by value. This pass by reference was just kind of a holdover from the previous signatures we used, which were a reference to an array, a slice, reference to a slice. So instead of a reference to an account filter, we'll just pass it by value, and then we can pass that directly into this temporary slice. Of course, lots of stuff still doesn't build, and yep, this is no longer called events, it's an event. Let's keep going down here. In the trait, okay, there's some problems with the references. This cute little iterator adapter thing, this chain of iterators isn't quite right because of types. And it looks like, right, so I'm trying to convert from a reference to TB transfer T into a value of Well, the type inferer hasn't figured it out. But this, I can't convert from a reference into the transfer type. I have to convert from a value of TB transfer T to the value type. So we can do that in our iterator chain by just calling dot cloned here, and that will kind of like bump up that reference to a value by creating a copy of it. And I think it there's a result. I want the result of something. What am I doing here? Okay, so this future is a future of a result. So that means I have to wrap this whole thing into an OK. I'll show you again. I'll look on the right-hand side of the screen here. These futures are not futures of vectors, as I've been saying. I've just kind of been, my eyeballs have been glossing over the resultiness of this return type. This is a future of a result of a vector of a return type, of a response type. So the reason it's a future of a result is because we may have an error type, or an error that affects all the responses. So down here, we're going to say this is an OK of this big iterator chain. Hopefully now the type inferer will get a little happier. Okay, much less errors now. And I did something wrong still. Submit get account. Okay, so this is in the test code. This is in main, not the library. This is, again, I just changed the argument from this method from a slice to a single value. So let's go over to main, and let's get that main.zig out of my Emacs buffers so I don't have to keep running into it when I tab complete. And submit, create, get account transfers is where we are. This is no longer a slice. No longer a slice. Okay, there we go. It all checks at least. And I'll go back over to the library and just give it another quick once over before we go try to exercise this code. So that's pretty easy. So much simpler than the code that we replaced it with, our group that we replaced. So in collect results, we had to do all of this to handle the multiple events, but in here we just collect the results and do a conversion all inline, a cute one-liner. That's nice. That's very rusty. The only thing to not like about this is that this code is now duplicated. But let's go test it first, and then we'll extract this. And what we want to do in our test, so this is the test. We're saying get account transfers. We're getting all the transfers for account ID 1. Account ID 1 is account 21. And I know we don't have an account 21 yet, but let's go test it anyway. And we should see, I would expect us to see 0 results, basically, like a successful 0 results. So let's go run it and see what happens. We see a warning, which is not good. Okay, we do see 0 results. Request equals 0. Why is this a warning here? I don't even understand what this is trying to say. Request equals 0. No idea. Why is that a warning? Is it going to give me another warning? Is it, don't know. I have no idea why that would be a warning or what that warning means. But the result seems to be right. Now let's try a get account transfers request when there actually is an account. So maybe that warning has to do with the fact that the account doesn't exist. Hard to know. But now let's make the account, and then we will make a transfer. So here, if we say test accounts, we can create an account and look up account. So we'll create a account up here, test accounts. And I'm really feeling like I need these like values to be extracted to constants at this point, but we'll keep slogging through it. I think they're all account ID 21, 22 at the moment. So we're going to create some accounts and then test get account transfers, and we should still see 0 results. Okay, still 0 results, but it did probably create an account. So it found account 21 and 22. These are the two that we created just now. Now we're going to test transfers. So we're going to make transfers for 21 and 22. So now when we look up those transfers, we should, okay, I think I'm doing something wrong. ID already failed. It looks like creating the transfers might not have worked. It looks like creating the transfers did not work. ID already failed. Result not found. ID already failed. So we tested the accounts. Test transfers. Submit create accounts. Creating two. Wait, just accounts. Test transfers. Let's get rid of this. Test accounts. Those accounts already exist now. Here we're creating transfers for account ID 21 and 22. Let's just try test transfers and see what it does. I expected that to succeed and it didn't. ID already failed. So you can see in test transfers, we are creating one transfer and then we're looking up that transfer. Oh, but up here, I'm not actually looking up. This is again, just manual testing code. I was looking up a transfer that didn't exist here. And this ID already failed probably makes sense because transfer ID. This probably, we already successfully created that transfer before. ID already failed. I'm very curious about what that means. So probably the database, when you fail to create an object, it is storing a record of that failure and then never lets you create that ID. Maybe. But why did this fail? So that we're creating one for account ID 1 and 2, and those accounts exist as far as I know. Let's create some new transfer IDs, 3 and 4. And here the transfers were created. Transfer 3. Okay, we created transfer 3 for these two accounts. That makes sense. We may never discover what that account ID already failed, that ID already failed error is about. But now we do have a transfer ID 3. So down here, let's try our get account transfers again. And test transfers. Let's leave it in there and see what happens. That transfer ID already exists now because we've created it. Okay, here we go. So now we do see some number of transfers here. That's great. So there's our ID 3. And let's go up see what happened when we tried to create. All right, so again, when we try to create the transfer with the same ID, it already exists, so it's failed. But the transfer does exist, and we did query it successfully. Let's run one little test here and create transfer ID 4. And this test code is getting to be pretty cumbersome. Starting to think it's almost time that we start writing a little test suite so we can just have repeatable tests instead of munging these values all the time to do exactly what we need. This transfer ID, what did I do here? 1, 2, transfer ID 2. Yeah, that's what I want to do. Okay, now over here, we see transfer ID 2. So confusing. Transfer ID 2, the variable named transfer ID 2 is equal to 4. So here, when we looked up our transfers, we have an ID 3 and an ID 4. So we have 2 transfers. And okay, so this is all working as expected. Great. This method is done for now. No, we got to do a little refactoring, but it all works. Let's commit this. And we are kind of getting to the point where I don't need to push anything right now. We are kind of getting to the point where I'm wary of breaking old code that we have smoke tested successfully. So I am starting to feel the need to think about a test suite. But this is all still working for now. And the thing I want to do before we continue is extract this code, because we copy and pasted this, and this is just super boilerplate. It also exists down here in collect results. So I'm going to call this I'm probably going to call this handle message, because I think, let's see, is anything here? We're pulling out the packet, the results, and the events. Oh, I think we are using, yeah, maybe I'll call this handle message. Makes sense enough to me. So I'm going to make another method called handle message. And it's going to return probably a tuple of packet, maybe not packet. Let's see, do we use packet down here? Packet, no. But we do use events here. Yes. So this is just going to actually return the input events and the reinterpreted result, given the message. So here's going to be the only input to this function, I think. Then the output is going to be a result of a tuple. And this tuple is going to contain the input events as a vector and the results as a vector. And we're going to need the input events are going to be as a Rust type or as a C type. I think they're going to be as a C type. And they're converted to a Rust type down here. And our new method doesn't even care about those events at all. They're just going to ignore them. So this is going to be, what I'm thinking right now is which of these type parameters I need. But I'm just going to copy this whole list of type parameters. And we know we need C event because it's used right there. Again, this needs to deal with C types and equivalent Rust types. And there's actually another Rust type here. This is going to use a C event and the C result. Nope, the Rust result. The C result and the Rust. It needs all these. I think it needs all these type parameters, but we'll see. I don't think it needs a result wrapper. I don't think it needs the result wrapper. But let's go figure it out. And copy. Okay, we need more type parameters here. This is a vector of the C event type and the Rust result type. I think that's what we need. I kind of don't remember what the role of this Rust result wrapper is offhand and where it's used, but it is included in there. So it might be, yeah, that is the returned result type, but this type is a C result type. So actually, I don't think we need the Rust types in here at all. I think this is what we need. We're just doing the unsafe conversion of that vector of C results. And this is actually, this is a slice. So we're going to have to return a slice and have a lifetime argument involved here. So it's probably going to take some iteration to get all this right. There's going to be some lifetime here. And we can possibly elide it, though completion with that the slice is created from raw pointers. So the slice is going to come out of nowhere. This is going to be interesting. We're going to have to name a lifetime and kind of fabricate a reference to that lifetime. So this slice is going to be owned by, this is actually pretty nasty. So this result here is a vector of bytes. This is actually really nasty. I don't like this at all. It's a vector of bytes, and we're reinterpreting it as a vector of slices. And this vector of bytes lives inside of this message. So we're trying to return a slice here, right? But that slice needs a lifetime in order for it to be safe. and it's a slice to the interior to a vector owned by this message, but it's a vector of a different type. So we're doing an unsafe cast to a slice of a different type. And that slice is going to have a lifetime into this message. So really, we can't pass this message by value at all here. We can't pass this message by value. What we need to do, this is pretty nasty, pretty nasty. We need to take this message by reference so that we can have that lifetime, and so that the message stays on the outer stack, so that we can tie it in to this lifetime here. This is very rusty though. Good problem to have on stream. And this is kind of like the level of unsafe and borrowing interaction that I can actually handle. like I can deal with this. More complicated than this, and it would be pretty tough to just wing on stream. But this lifetime and this lifetime have to be tied together in order to unsafely fabricate this slice. So we're going to give this lifetime a name, and I don't remember if lifetimes come at the beginning or the end of the type arguments, but I'm going to put it right here. I'm just going to call this stack. And really, lifetime elision would handle this for us, since there's only one lifetime involved here. Like if we didn't name this, it would be these two lifetimes would just automatically be tied together, I think. But because we're also fabricating this lifetime unsafely, I just want it to be very explicit what we're doing with the lifetimes here. Okay, so that's probably enough to do this. And we're gonna have to restructure how this is organized, because again, we can't pass this message in here. Before, I was thinking, in order to, this function I've defined as returning the event vector. The event vector is contained in those messages though, and I can't move that event vector out if I'm taking the messages by reference. So I can no longer do this. And really, this handle message is mostly going to be dedicated to doing that unsafe slice conversion, while also checking this boilerplate array handling. And again, this boilerplate array handling may expand in the future. So I'm still thinking I want to encapsulate this code into a function, even if this function is going to be kind of slight. And the structure of this function is kind of wonky because of the dealings with the inability to move out of message and the need to tie the lifetimes together. But I still want to go for it. So the first thing I'm going to do is just kind of copy this up there. And it's going to have to be different now because this message is now by reference and not by value. So I can't just do this anymore. But I will say I'll take a reference to packet. And these events, I don't think I actually need in this function at all. So I don't think I need, oh, I do need the type argument there though, but I don't need to touch the message. And this result, I again can't move that result. I've just got to leave it in place. This all doesn't need to change. And this looks probably okay. This result is now a reference. How are we using it? Result has pointer, result. Okay, we're just calling methods on it, so that should all work. So this is creating an unsafe reference read-only to this slice as a different type of slice. This should work. And here's a error return, so it has to return an OK here. All right, so let's type check this and see if our new design for this boilerplate works. Cargo check. And some typical stuff here. Expected at least one generic argument. Yeah, this is not the right type here. This is a C result. Okay, so that checks. Checkpoint our commits. And now we kind of got to restructure all these callers to be slightly different. So let's go do the one that we've been working on. So here we have our message, and all of this is going to go away. And instead we're going to say let result equals handle message. And I think the types are going to all be inferred here. And we pass a reference to message into it, and it's may return an error. So that's all I think we have to do here, which is nice if true. This is pretty code. Let's type check that. Type must be known. Okay, the inference didn't completely work through all this. There's a lot of inference going on in this chain right here, so inference is not going all the way through that chain for reasons that are too complex for me to imagine. But our result here needs to be a slice of C result here is a TBC TB transfer T. And we could also pass these type parameters here, but one of these would probably need to just put a blank here. Just syntactically, there's always a choice whenever you need to hint a type to generics, whether you put it here or put it up here on the method call. But here I think this makes a lot of sense to leave it up front. Okay, so that checks. And let's run this and make sure this looks like it is still basically doing the right thing. Get account transfers, finds 2 transfers, looks like it's still working. Yep, and during this kind of refactoring, it would be nice if we had a little test suite so we don't break things. But we're gonna live dangerously and go refactor these other methods to do the same thing. And we don't need to refactor the other methods. We just need to refactor collect results. So let's open, fun collect results here. So inside of collect results, this stuff is all going to change. And let's just get rid of it. And really, this can look pretty much exactly like the code we just wrote. Let's go find it. So here, we should just be able to do this. And then this is a generic type, C result. And then down here, we still need that event vector. So here we'll say let events equals message.events. And here we can move out the events. No, we can't move out the events here anymore because we're holding this reference. So this reference is basically locking that message. That message can't be mutated anymore. And this will destruct the destructure the message. So this shouldn't compile. Let's go verify that. Maybe Rust is very smart about that, but I doubt it. Yep, can't move. You can see exactly. Let's see what the compiler said. Can't move out of message events because it's borrowed. Great. Exactly what I said. That's exactly what I said. But we can take a reference to events. And here we're iterating over events, so we can't do that anymore. We have to, oh yeah, that's right. I was thinking like maybe we're doing a move iterator calling into iterator, but we're not. We're doing a reference iterator. So this should still continue to work just like this. Great. And let's again, one more time, run everything and oops, go look at that. And it seems to be working. These errors are expected errors. I'm very curious what these warnings are. This might be a new thing in the client. It makes me wonder, there's a PR up in Tiger Beetle right now to restructure how the client does batching. And seeing new warnings that I've never seen before makes me wonder if that PR went in and I'm doing something wrong now. But it all still seems to be working. Let's see. Just checking the time. This might be enough for tonight, chat. We've accomplished a nice unit of work, and it's about dinner time where I am. Let me see this diff. Yeah, this looks great. So next time, so we finished implementing something, one of these methods, one of these request methods, and we have several more to go. So let's go back to the state machine real quick. And these are all the request types. We've done we've done all these, and we've done this one. So probably the next, oh, we're so close. Maybe I'll come back tonight and just finish this. We're so close, but each one of these is taking like an hour, 90 minutes to implement, with all the chat stuff and also the brain stuff. It's not just chat's fault. Chat plus brain. It's the brain's fault. So we've done a get account transfers, and that seems to be working. Next we'll do get account balances, and that should be just boilerplate. Like it should be the same as get account transfers with some change types and some new struct definitions that are just mirrors of the C definitions. Should be very easy. We'll plow through that quickly. And then these two, we haven't seen these before, but they're also query methods. So that makes me think they'll be similar. There's more query methods. They should be similar. Another thing to think about here, okay, I'm going to wrap up this code, kind of get toward ending this. Oh man, the screen looks great, doesn't it? Always tweaking my lighting. So another thing we need to think about, these are queries, and we have to start thinking about, like, what does paging mean? Like, how do we page queries, or how to create a cursor? I don't think there's a cursor in TigerBeetle, but how do we page queries in the Rust client? And I actually don't really know how TigerBeetle handles paged queries either. I suspect it's using like timestamps, because every type, every value in TigerBeetle has some kind of monotonic timestamp, I think. And I suspect it's using timestamp ranges to say, like, query, like, look at the last set of results I got, and then, set the timestamp to the last timestamp, and then go do another query for the next ones. But I don't know if it's using timestamps for paging or not. So at some point, when we're doing these query methods, we got to think about, like, how is the user actually going to do paging? And all the data is going to be there, like with what we're implementing right now. Like, the data is going to be there for them to do paging manually if they want to. But also, it really seems like something we should consider giving to them, just doing it for them, because paging it's not going to be trivial. And it's boilerplate that the client probably doesn't want to implement on their own, or we shouldn't have to implement on their own. But also probably not necessary for an MVP. If we really want to kind of move forward fast to get something in tree so people can look at it and start giving feedback and testing it. So this is basic functionality, like the core protocol functionality is kind of what we just need to get done right now. So next time we'll keep going. We've got three more of these methods to implement, and then probably going to make some kind of basic test suite before we submit anything. I think it'd be a little irresponsible to not have some basic confidence in the code before we ask people to go give it a shot. And then we'll submit it for review. And then after that, there's going to be, many more streams of cleaning up and documenting and testing and examining performance. But, we're basically almost to our MVP at this point. Oh man, so today's stream was interesting. I started off with that cough. That was pretty rough. Good experience though. Got to handle that somehow. And my name is Brian. Burson on GitHub, BRSON. My socials are on my GitHub pages you can find from GitHub. I'm doing this stream irregularly, but a few times a week. I usually announce it on my Mastodon and on the TigerBeetle Slack about 10 minutes before I stream. I don't have a regular schedule, but I may at some point in the future have a regular streaming schedule. All right, thank you very much, and see you next time.